The level 4s in this skill are going to be really the same level 4 that we had in our last skill, where we're making models and either maximizing or minimizing a certain quantity. In the last skill, we mostly dealt with quadratic functions. Now it might be other, like we might have a cubic function or other polynomial functions. So looking at this example, it says a woman is creating a box with an open top by removing squares of equal size from the corners of a sheet of metal and folding the sides upwards. If the sheet of metal is 2 feet by 2 feet, what is the maximum possible volume of such a box? Okay, so we have a sheet of metal that is 2 feet by 2 feet. And she's removing squares from the corners and then folding these little sides up to make a box that is an open top box. And so the volume of this box is what we're supposed to figure out. The volume of a box is length times width times height. But with these models, we want to have everything in terms of one variable. So I'm going to call this side length of the little square corner that we're cutting out, I'm going to call that x. And since these are squares, this would be x, this would be x, and all of these would be little x's. Now, when you fold the sides up, the box will probably look something like this. Okay, and the height of this box is going to be the dimension of that little square that we cut out, x. And then the length and width, we need expressions that are in terms of x. Now, if this whole side right here is 2, the expression for this little part, which I'm going to write on this side, is going to be 2 minus 2x, because I would subtract these little x's that we cut out. And then this part right here, since that length is also 2, is going to also be 2 minus 2x. So this dimension is 2 minus 2x, and so is this. And then my formula for the volume of this open top box is going to be the length times width times height. The length is 2 minus 2x, the width is 2 minus 2x, and the height is x. And there is a formula for the volume. But my goal is to find the maximum possible volume. So I'm going to plug this formula in my calculator in y equals. When you graph this function, you don't need a very big window because remember our x is going to be pretty small. If this whole side was 2, x is going to be less than 2. It's going to be less than 1. So the graph looks something like this, but the only part of the graph that we care about is this part. And we want to find the maximum point on that graph. And we get the point about 0.33 and 0.59. So remember that the x is the dimension of that little square that we cut out, and the function represents volume, so this would be the maximum volume. So maximum volume is 0.59 cubic feet.